One of the fundamentals of data warehouse design when we're talking about doing dimensional models along lines of a Kimball dimensional data warehouse is that we're going to organize our relational data warehouse into a star schema. And it's why do we do that? Why don't we just design a data warehouse the same way we design a transactional database? And we're going to talk about that for just a couple minutes. So we're going to come back to this design. This is a collection of tables that makes a very, very simple data warehouse, and you might just call this a data mart because there's not that much here, but it'll be very instructive. But before we look at that, let's take a look at our more typical third normal form transactional database. And when you look at one of these, you see the first thing that hits you is there's just a lot of tables and a lot of complexity in the way that they're joined. So we see joins that go through tables and keep going and continue on to other lookup tables that continue on to other lookup tables. And this all is excellent modeling for a transactional system. It keeps the amount of redundancy in tables to a minimum. It makes inserts very efficient. It makes updates very efficient. If the category description for a product or if the model name for a product it changes, I don't need to change the product table. There's a model table that has that information that's updated in one place, and it doesn't need to affect that many rows in this table. So this is fantastic stuff for transactional systems. But to query this kind of a database is just daunting for most people. If you understand this design completely, it's great. If you don't, you're going to spend the first couple of weeks working with this database just trying to figure out what's in it. It's not intuitive for users that aren't expert in its design. It's also not efficient from a query perspective in terms of joins. If you want to extract a lot of information and slice and dice out of this kind of a database, you're going to be joining maybe a dozen of these tables on each one of your queries. And so that can be a problem. From a performance point of view, the engine's going to work really, really hard, and the queries are going to be really, really difficult. So to solve some of those problems and challenges, I should say, in a star schema design, we really flatten things out. So we try to minimize the number of joins that we have between the metric data, like the sales data in this table, and the areas that we're going to slice that data by, such as items, store, time, and so on. So you will notice in the item table, and this is a bit more simplified, but we don't have a separate category table. We have the category description right in with the item, and if we looked at that table, the category would be repeated over and over and over. And a transactional database designer would look at it and go, "Oh, that's terrible. I mean, it's so denormalized. It's not efficient, and that's just the wrong way to design a database." Which is true if your goal is to design a transactional insert database. But from a query standpoint, it makes it super easy for the users. And honestly, in most data warehouses, the 98% of your storage is in this fact table right here. These others are 2%, so the waste of space, it really doesn't matter. But why do we call it a star? Well, quite simply, we call it a star because that's what it looks like. So if we look at this schema, when we're done with it, we actually have something that looks like a star, and so we give it the name star schema. So a silly reason to call it star schema, but that's pretty much it. But what you're looking for in these is that you don't have a lot of joins. So really, for any query, we're going to have one join to get any piece of information in any direction, and we'll take a look at a query that uses that. Now, I will just mention very in passing, you might hear the term snowflake schema, and what a snowflake schema means is just that our star is developing a little bit of a, well, let me put a couple of attributes in here. Our schema is developing a little bit of I'll call this model table here, is developing a little bit of more complexity. And let's say I had a model table that was connected to my items, and I put it over here, and I then connect it to the model table. So now you see I'm not really a star anymore. I'm starting to look like something else. And if you think of the way a snowflake looks, you get this kind of radial spider pattern out that keeps going. So some people think snowflakes are bad. Some people think they're fine. I'm a little agnostic about this. Sometimes it is necessary, but one thing to keep in mind is this model key that we put out here. We need to have a key in this table that refers to the model table. We could just as easily put these attributes into the item table itself, and that design would work just as well. So there will always be a bit of a disagreement on whether to snowflake, not to snowflake. If you get too carried away with a snowflake design, you are right back to a third normal form database. So be cautious with that. So that's what the star schema looks like. Let's just look at why this makes query so much easier, and it works pretty much like this. So here's sort of a typical query that we might do on a star schema, where we're just saying give me sales, and I'm doing inner joins, and each of these joins is just going in one direction. So we're not doing inner join item and then joining from item to something else and that something else to something else like we would in a third normal form database. So to get any piece of information, we just have one join out to a dimension table. We have a where clause here. And if we want to drill down, we just keep adding to the where clause. So that's my sales for the week. And if I want to drill down and give me just the West, I can do that. If I want the category, I do that. But because all of this information is in these nearby dimension tables, it's very quick. So this query is very simple, it's easy to follow, and it's pretty easy for end user tools to do this kind of thing where you just keep adding to the where clause in order to drill down. So that's what a star schema is about, that's what it looks like, and that's how we use it.